Problem 87, we're taking a look at a geometric series. So the first part A, we have 3 is our first term, 10 is our multiplier. We can tell it's in first term form because it has the n minus 1. So it wants us in problem A to write the first 6 terms. So we have 3. Then 3 times 10 is going to be 30. Then 3 times 10 squared is going to be 300. And then I have 3,000, 30,000. And the last one will be 300,000. So adding all those up in my head, I will have 333,333. Problem B. We want to use this strategy, explain the strategy that these two are using. So the strategy that we have is if we take this series that we just created, and let's call that the sum. And if I take that whole series and I multiply it by its multiplier, so if I take this whole thing and I multiply it by 10, now 3 times 10 is going to be 30. And then 30 times 10 is going to be 300. And then 300 times 10 is going to be 3,000. And you can start noticing that all I'm doing is I'm just actually writing the next term. So then I would have 30,000, and then I would have 300,000, and then I would have a new term that is not part of this series. It would then be 3 million. And that will equal 10 times the sum. Now what I'm going to do here, let me clean up a little bit of this, is I am going to subtract the top one from the bottom, or the bottom from the top, rather. So when I subtract them, I will have 30 minus 30 makes 0, 300 and 300 makes 0, and all of these cancel. So the only thing I have on the left side of the equal symbol is my new last term, which is 3 million. Minus 3, because I still have that. And that's going to equal 10s minus s is 9 times the sum. And then I will divide both sides by 9 to get the sum by itself. That'll cancel out. So my answer will be 3 million minus 3 divided by 9. So problem C. I want to write this in summation notation for the first n terms. So, get my sigma. That means n will be up top. So on the bottom, I'm going to use some variable. It cannot be n because I already have n on top. So I'll just use p. P equals 1 to n. My equation, written in first term form, is right here. So 3 times 10. And now my variable that I use here has to match my variable here as well. So I will have to the p minus 1. And that is my summation notation. The sum for that is going to be, my last term is 3 times 10 to the n minus 1 when I put n in, times my multiplier of 10 minus my first term all over the multiplier minus 1. I am going to simplify that though, because this right here, when I have a base of 10 for both, I can simplify that down to just 3 times 10 to the n minus 3 over 9. The reason why I can write it as 10 to the n is because I have 10 to the n minus 1, and I have 10 to the first, and I add my exponents. N minus 1 plus 1 is just n. So here's my summation notation, and that is my sum for the first n terms. Hope that helps.